Hello, am I audible, sir?
Yes, ma'am, you are audible.
Okay, fine. Nilu,
Yeah, ma'am.
please introduce about.
Yeah, ma'am. Good morning, one and all. Am I audible?
Yes, ma'am.
Yes,
Yes, ma'am.
yes.
Okay. Thank you. Good morning, one and all. Speaker for today's session is Dr. Aditya Nigam. Dr. Aditya Nigam is presently working as an assistant professor at School of Computing and Electrical Engineering, IIT Mandy. He has published about 53 articles in various journals and conferences of international repute. His research interests are deep learning, biometrics, medical image processing and its analysis, image processing, computer vision, and machine learning. We welcome you, sir. Thank you.
Yes,
Hello.
sir. Yes, sir. You can
Yes,
start.
ma'am.
Yes, sir.
Okay, fine. So I request all the participants to please mute your microphone, and if you have any questions or doubt or anything that you want to say, then at that point of time you can ask, or we can at last have some time to discuss about the thing that we have discussed, right? Yeah. So I need to um, project my screen. So I assume that you can see my screen. So if you can see, then you can write in the chat box that you are able to see my screen. In the chat box, you can write. Oh yes, it's visible. Okay, thank you very much. Yes, so let's start about this topic, that deep learning and its magic. So our plan is my plan is that in the first lecture I'm going to talk about basics of deep learning, what are the things that are being done using deep learning, and what is the meaning of such a deep networks, and how it is being different from the traditional machine learning, and what are its application. And then we'll see a very specific component of deep learning that we used to say as convolutional neural networks, and how these convolutional neural networks are actually working. Yeah, so starting with the basics of say any artificial intelligence system, is that we need to train a machine that can perform some task very efficiently. And if it can do that, and that machine itself is in a position to do a task, then we say that it's actually artificially doing the work. And intelligence means that you keep on doing some work for some good amount of time, and then you understand that if I how can I use my such an ability to convert into the you know the knowledge skills that I have got, how can I apply these knowledge skills to solve different types of problems. So artificial intelligence in broad way can actually be seen in that way. And if I say that such a task, then one such task we can talk about, that how we can learn, how we can do certain tasks. So if you have a task, then you will say that I'm going to give you some input, and corresponding I'm interested to get some output from you. So from X, we need to understand that how we can get up to this Y, and most of the time this X can actually be certain images or some different type of data. And given this data, there is some label which is associated to it, and this label is mostly, we say it as some Y label is being there. So how we can train such a network, or maybe come up with some method by which I can convert this X into this Y. So if I can convert this X into this Y, I need to train my my algorithms in such a way so that whenever I used to get any X, I am able to give you the corresponding label. So suppose that I have huge amount of cat images or dog images, and then say that my task is to come up with a classification algorithm which is differentiating between cat and a dog. And while training, if I have labeled data, which means to say that I have huge amount of data over which I am going to train, and for all of these images, I know that this is cat, this is cat, this is dog, this is dog, this is cat. And when I have got a model, I will show this and say that after seeing this after seeing this image, this model need to tell me whether it's a cat or a dog, and then I can somehow figure out the relationship that whether I was correct or incorrect. So that is why in the case of supervised learning, because you have these labels, we have a mechanism which can somehow tell us that how well we are predicting over our training data. And once you know that what is the actual label, you can always find out that what was the error. And once you know that how much amount of error is there, you can always come up with ways by which you can somehow correct this error. So first we are going to talk about the classical classification problem, in which we are saying that we have a cat versus dog images, in which we have huge amount of cat and the dog images that we have in our training data. And we come up with, and in I assume that in the last day lecture, Dr. Kamlesh Tiwari was talking about the basics of neural networks and also. So given any data, or suppose that this is my training images, all of these are actually my training images over which I am working on. And given such a training image, I convert them into different certain features. And once I have got for each and every data, we apply certain algorithms and we get these feature values. And these feature values, suppose that they are two-dimensional right now, because I have plotted them into a two-dimensional graph. So if they are, suppose that two-dimensional, that from this cat I only computed, from this cat image I only computed two information, or the two-dimensional feature vector, then this is one cat image, this is another cat images feature, this is another cat images feature, and these are some dog images feature. And we are assuming that if we have good feature vector representation, then classification algorithm need to actually this classification algorithm need to come up with such separating line. In such a case, it's actually in two-dimensional case, it's actually a line. So it need to actually come up with a line which can differentiate between a cat and a dog images. So suppose that instead of this two dimension, I am having 128 dimensional feature vector. Then in that 128 dimensional space, very high dimensional space, one cat image can actually be seen as a point like this. And instead of this line, you are going to you are going to somehow come up with a hyperplane, and that hyperplane need to separate this cat images and the dog images. That is the requirement of any classification algorithm, to somehow come up with a hyperplane or maybe some non-linear boundaries. Later we will see that non-linear boundaries, so as to which can differentiate between cat and the dog images, or class 1 and the class 2 images. So that is the work of a deep learning algorithm. You all must have seen that in the fully connected network, or given any single single layer neural network or single neuron. So first we need to start with the data. From this data, we are trying to somehow come up with some features, that given this data, what are the features over which we are interested to work on. Once you have got these features, and for this several times what the case was, that we need to dependent upon the handcrafted features like shift, surf, hog, huff, and so many different types of features which are anyways being available and present in the literature. They used to talk about that from this data, if your final classification task is being predefined, then what type of features that one should have to be extracting. And huge amount of work was actually being done previously, so as to come up with some some set of predefined, or one can say handcrafted features. So once you have got these features, then we require some classification algorithm which is going to somehow solve and going to give you this hyperplane. Once you have got this hyperplane, you can do classification, which is actually going to tell that one side is one class, other side is another class. You have two sides and basically two different classes. So 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 if you have one neuron, and then you can see that one neuron can actually learn one such hyperplane, that we will see that one neuron can actually learn one such hyperplane. And once you have, and if it's actually a supervised learning, then once you have learned this hyperplane, you will say that how well is this my hyperplane. And because it is supervised, then with respect to the hyperplane you just have learned, suppose that this is my hyperplane, you take each and every training data and see that what is its classification with respect to this hyperplane, and what is its actual label. And then you can somehow define that what is its corresponding error on the loss. And every time whenever you wanted to update your hyperplane, you are going to use this loss, and basically the derivative of this loss iteratively updating your hyperplane. Let us see one example in which I am having one such a neuron. I'm having only one neuron, and this is my training feature vector. This is my data number one. This is my, if I write it, that this is my yes, that is my data one. That is my, suppose that class one, and some data of any class. So suppose that it's actually cat image number one. And out of that I have extracted these four features, and one neuron is there, and this neuron is actually looking for and getting all the information. So this neuron is actually taking all the input input feature vector, and this whole input feature vector is being fed to one neuron, and one neuron is actually having multiple weights. So it's actually saying that this neuron is trying to see that how much amount of weight I should have to give to this feature vector, or this or this or this. And these weight vectors are initially unknown. We pre-initialize them in order to train one such a neuron. And what is the abstraction of computation this neuron is doing? It is just doing some aggregation, that w1 x1, w2 x2, w3 x3, w4 x4. And if this value is more than or less than a particular threshold, value is more than or less than a particular, hello,
Sir, your PPT is not visible.
PPT is not visible. Yes,
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 it's
that's what I was actually looking. Wait, um why it has happened? Okay, stop sharing. Why it has sharing? Start broadcasting. I'm sorry, something has happened in between. Is it now visible?
yes, sir. Yes, sir.
Okay, thank you very much. So if something like this happen, I request you, the one who was actually pointing out, only you can see, and please tell me that if this thing is being repeated or any other problem. Thank you. Yes. So what I was trying to say is that this neuron is just trying to aggregate whatever the input feature that we are getting with respect to these weights, and we just do this w1 x1, w2 x2, w3 x4, and w4 x4. These are the four values my neuron is actually learning, and we just need to check that whether it is more than this w0 or not. So most of the time this w0 is actually being called as the bias of this neuron. So this neuron is keep on aggregating the weighted response of all the inputs or the input dimensional feature vector that we are having, and and just checking that whether it is more than a threshold or less than a threshold with respect to that thresholding. This neuron is going to say that whether I'm going to fire or I'm not going to fire, or basically I'm going to give a signal high, 1 or 0. So neuron is going to fire or not fire depending upon the whatever the output that we are having. And so this is the basic that we just have seen. Now let us take few questions if you are interested with respect to this issue. If you have any question, then you please ask. You can unmute or raise your hand, and then I can answer. I mean, because I assuming that everything up to now was being covered in the Kamlesh Tiwari's lecture. So if you have any question, I request that please ask. You can unmute yourself, or you can raise your hand, and we can give you, option to speak. Or you can write in your chat as well if you are interested. I'm giving you say 30 seconds. Okay, I assume that um, nobody is right now asking. Okay, so let us go and talk about the next section. What I just have covered is that how one neuron is going to learn, and one neuron is going to see the input. It's trying to learn. It is trying to learn different weights, W1, W2, W3, and W4, so that over that whole training data, X1, X2, X3, and X4, four features that we have got, maybe for all training data, how I can come up with these WIs, which can actually differentiate all of my training data into its correct class, and which means that I need to know what is the weight vector which is going to minimize my error over the training data. And essentially what we are learning, W1 X1 plus W2 X2 plus W3 X3 plus W4 X4 greater than or equal to 0. Let me ask this, and those who know, please write this thing in your chat box. That what if I have, four-dimensional space like this. In this four-dimensional space, if I plot this equation, what sort of, structure that I am going to see on my graph, or in that space, in that four-dimensional space, what we are going to see if we plot this equation. You can please write that thing in your chat box. I'm sorry, I will be slightly interactive. Plane, Mithilesh Kumar, yes, it can be a plane, but since it's a four-dimensional space, then we will not be saying it as a plane. That's a hyperplane. That is correct. That's going to be a hyperplane, and I am sorry, continuously I will keep on asking small things so as to all of you being engaged into the lecture. So if you know something, please write. If you don't know, whatever you are thinking is correct or incorrect, don't worry about that. Please keep on writing and asking things so that I can build this whole lecture with respect to and tailor it according to you. Yes. Yes, so this is understood. This thing is fine, that these weight vectors that we are learning, they are nothing but the coefficients of that hyperplane, and they basically we need to learn for the classification. We need to learn a hyperplane. Which type of hyperplane? Such a type of hyperplane that can differentiate class A and class B. If it is two-dimensional feature, we are going to get a line. Three-dimensional, we are going to get a plane. And if it is more than that, we used to get a hyperplane. Okay, fine. So before going to start about, and I assume that that was actually the single neuron. So let me also give you some brief introduction about if you have multiple neurons. So one neuron is actually going to see my training data like this. This is my training data. I have another neuron. It's also viewing the same training data. What
So
is
you
that
have
going to?
a question. Huh?
Yes.
So what is a hyperplane?
No, hyperplane is that. Right. So it is that if I am having a two-dimensional, it's actually a line. If I'm having a three-dimensional, then I'm going to get a plane. And when you are going to get a line, if it is say X and if it is say Y, and if I have a linear relationship between my dimensions, this is essentially a linear structure that you are going to see in your graph. So if it is two-dimensional, and whenever I say that ax plus by is equal to c, this is always going to be a line because it's a linear. I am having x and y. There is no second order or third order things. So if I say ax plus by plus cz is equal to d, that's a plane. That's going to be a plane for me. And if I say that ax plus by plus cz plus k times lambda, that's going to be equal, and that's equal to some gamma. So this is going to be a hyperplane. And it's actually that in how many dimensions I'm having: x dimension, y dimension, z dimension, and lambda dimension. So if you have anything which is more than 2 dimension, more than 3 dimension, we always say it as a hyperplane. Is that okay, or do you require any other explanation? Please let me know.
Question is that why this is greater than W naught? W naught.
Yes.
Aditya Nigam, is it? Sorry,
Yes,
sir.
Please say yes, ma'am.
Uh, why this should be greater than W naught?
Yes, so let me answer it in that way. Let us see that if I have a line like this, and again I'm going to ask one question, that suppose that I am having some points over here and some points over here, and this is actually 2 dimension. I am having x1, I am having x2, and in this 2 dimension I have got a line like this. I guess that everyone is okay with this, that I have got a line like this in which I am having features like x1 and x2. Two things are here. If I have a line, can anyone tell me how can I know that a point is to my left or it's to my right? How can I know? If I give you a line and if I give you a point, how can you tell me that this point is to the left of my line or right to my line? Just Lina Sayyed is perfectly correct. What she has said is that, yes, somebody else has also said, let me see. Yes, coordinates. So coordinates, if I give you coordinate, you need to tell me, Priyanka, that whether it's to the left or to the right. So Rini is correct again. Whether it's to the left or to the right is only going to be suggested by, I take that point, place it on the line and see that whether it is more than 0 or less than 0. So 0 is actually coming when I represent my line, as, let me show it, when I represent my line as ax plus by is equal to c. Suppose that this is my equation of my line. If I represent it ax plus by minus c is equal to 0, the same thing. Now you will say that if you have point x1 and y1, you place it over that and then see that whether it is positive or negative, and that is going to tell you that whether it is belonging to class A or class B. Right. Now if I say that I am having basically 3 parameters I need to know: A, B and C. So this is the parameter that we wanted to give the amount of weight to my x variable. This is the amount of weight that I wanted to give to my y variable, and that is the bias of my neuron, which is actually telling that whether it is more than this threshold or less than this threshold. So this W0 is essentially this thing, which is going to tell you that whether it is class A or class B. Is that okay? You can write in the chat as well. That is that okay?
Yes, sir. It is clear.
Yes, sir. This clear? Okay, thank you. That's clear. Now let us go, and one small thing that I wanted to say is that just wait. Yes. So one neuron, it can learn one line for you. One neuron can learn one line for you, and I assume, and line is actually hyperplane for you basically. If and that depends upon the input dimension of your neuron. Now, if I have another neuron that can learn another hyperplane for you, and if you have, so that can actually be said as the first layer, in which you are having one neuron number 1, which is learning one line for you. I'm having neuron number 2, which is learning another line for you, and then I am having another neuron, maybe my second layer, which is having another neuron. This is again one neuron, and this neuron is actually learning what? This neuron is actually learning how much weight I need to give to this decision and this line. And if you somehow give this thing to this n3, this n3 is going to tell you that probably I can learn a space like this. I can learn a boundary like this, in which one class is here and other class is here. So you can see that this first two neurons are actually trying to learn. First two neurons are actually trying to learn hyperplane, and the upcoming layers neurons are actually trying to learn non-linear combination of these lines. It's actually non-linear combination. Right now it's a linear combination, but you can actually learn things like this. And that is actually being covered in the, whenever I used to cover the fully connected network. So this is actually a fully connected network in which I am having one neuron, another neuron. This neuron is connected to each and every input. Let me draw it properly. That this, suppose that I'm having four-dimensional input, then this neuron is connected to everything, and this neuron is also connected to the everything, and whatever you are getting, this neuron is giving you some output, this neuron is also giving you some output, and these two outputs are actually connected to my this neuron with another set of weights which are going to be with respect to this neuron and need to be learned properly. So here this neuron is learning a line, this neuron is learning a hyperplane, this neuron is learning a hyperplane, and this neuron is trying to learn a boundary which is actually a non-linear combination of the hyperplanes that we just have learned. And it may learn this, it may learn something like this, or it may started to learn non-linear and much more complex surfaces that can be between two classes, because every time your classes are not going to be linearly separable. Yes, so this was the thing that I wanted to talk about fully connected networks. You can see that why they are fully connected, because each neuron is connected to each of the previous layer neuron, as well as here one neuron is there. It's actually connected to all the previous thing. In this layer, you probably have one more neuron, and if you are having one more neuron, it has to be connected to the all the previous things. That's a fully connected network for you. You can ask any question if you have in between. Yes, sir. In what cases we need a second neuron? See, oh, if that is the case, then probably first basics are also not clear. So for that, I need to show you once. Wait, I understand. So wait, please give me 1 minute. I need to show you something else. First of all, see, this is one neural network for you. Okay. This is my input layer, which is saying that I am having data, maybe my cat images, and from these cat images, one cat image, I choose, show it to my network. What is this? The data or the feature representation of that cat image. This is my first hidden layer. This is my second hidden layer. This is my third hidden layer, and that's my output layer. Clear? Clear. Now you can see that this hidden neuron, this is one neuron, and it's connected to each and every input. Any neuron you take here, this neuron is connected to each and everything which is in my input. That is why it is fully connected network. This is my fully connected network. Okay. Now you see that what this neuron is connected to, that's a hidden layer number 2. This is connected to all the previous layer things. So these are input. So this neuron is actually going to learn a hyperplane. This is also learning a hyperplane. This is also learning a hyperplane. All of them are learning different sort of hyperplanes. What this neuron is learning? This neuron is learning how can I merge these hyperplanes in such a way so that they are linearly, so that they are non-linearly associated, and I started to get a boundary like this, some sort of boundary. So all of them are actually some non-linear combination of my previous layer decisions. And if I keep on doing, what you are going to get, then we are going to get, let me show it to you. In the very last place, I have something for you special. Wait. Yes. So suppose that, so here it's also being shown that this is actually a multi-layer neural network in which I have one neuron. It's actually seeing X and Y, both of these things, and giving me some decision like 7, whether it is belonging to some class or not. So that is the decision of this neuron. X and Y, same X and Y, and it's being shown to this neuron. It is saying that I am having also some decision for this neuron, and this final neuron is actually trying to combine both of them, because it is learning that how much amount of weight I need to give to the first, this neuron's output and this neuron's output. So you can see that this neuron is actually trying to learn something like this. This neuron is trying to learn something like this. And when I learn a weight by which I can non-linearly combine the decisions of these two neurons, I may actually get non-linear boundaries like this. So So now you can see that, yes. So if you have two dimensions, only two-dimensional input. If you have only two-dimensional input, one neuron is learning this, other neuron is learning this, and the final output layer is actually trying to learn something like this. Is this okay? Please, you need to say that yes, you understood, or need to explain it over here. That if I have two neurons, you can learn. Yes, sir, Vishnu Chakravarti. Good, good. I'm good. Good, good. Anyone wanted to say anything? Yes, I guess that this is okay. That you have got one neuron, you have got another neuron's output, and the finally you have got non-linear boundaries like this. Somebody has asked that when to merge multiple neurons. That is the question. So let us see that instead of that, suppose that I have three neurons. This is my input. I'm having neuron number one, neuron number two, neuron number three. Their combination is going to be learned like this. Yes, let us see. Is this okay to everyone? Again, you can write yes, no. Is this okay to everyone? Yes, Yogini. Yes, Aparna, Jasleen. Yes, I understood that you all are now getting. So I have got X and Y, multiple such things, and it actually learns a completely convex surface like this, that things are in between. Other things are completely outside. You will not be in a position to come up with any hyperplane, single hyperplane like this, which is going to give you the performance like the way you are getting a boundary like this. And you can learn such a boundary if you have three such neurons. Now let us see. Instead of two dimension, if I have three-dimensional input, then first layer is going to learn a surface for you, basically a hyperplane for you. I'm sorry, and this is not a hyperplane. This is a plane because it's a three dimension. So you are getting a plane. The second neuron is learning another plane, and the combination is learning a surface for you. I assume that this is also okay because you are getting three dimensions. So you are getting plane, and their combination you are getting orbit surfaces. So your one class can be over here and other class can be over here. Okay. If I have scaled in multiple layers, then what you are going to learn? This is my input. This is my first layer. You can see that still they are learning the hyperplanes for you. This is learning the nonlinear. This is learning the nonlinear combination of whom? Their previous layers nonlinear combinations. This is also learning a nonlinear combination which has to be different from the this neuron. This has learned a nonlinear combination. This will learn a different nonlinear combination. What different nonlinear combination it is being learning, depending upon that this layer has got multiple complex surfaces, and the final layer now you see that can learn the nonlinear combination of these surfaces. So the boundaries that you are going to learn, you can see that here simple, slightly complex, much more complex, and if you keep on adding more and more hidden layer, you keep on getting much more complex boundaries. You can see that it's not a single line like this. You can see that it's not a convex surface like this. This is actually almost like a surgical strike, that right now going, and then you need to go inside and need to come outside. And how can you learn such a thing? You need to have much more complex surfaces. So that is the reason you require more and more layer and more and more more and more layers, and more complex surfaces can actually be learned. Yes, is that okay? Right. So this is the thing that I wanted to show, and then we will. Yes. Okay, sir. Fine. Good. So I guess that you have got this stuff. Yes. Any question? Then please ask. Yes.
Sir, excuse
Yes.
me, sir. Good morning, sir.
Good morning.
Sir, can you just show me the slide in which two hidden layers were there just now?
Yes.
Sir, in this first hidden layer, there are two neurons which is learning linear, right? Linear.
Yes.
The second hidden layer is just going for non-linear learning, right? Just
Yes.
opposite of that. So is it the correct learning, sir? Is it correct?
Yes. Let me tell you this thing one by one. Actually, I assume that in the first lecture, Katie must have covered this stuff, but I'm rephrasing because it's almost okay that what this neuron is learning. This neuron is learning W1 and W2, right? So this is going to get W1x plus W2x greater than or equal to W0 for the bias. And you can see that essentially it is learning a line over here. This neuron is also learning a line which is different than the first line. What this neuron is learning? This neuron is giving W1 weight to this and W2 weight to this. Okay. So you will say that, okay, it's also going to learn it's also going to learn a line for you. Now there is one catch that I didn't have said, and that is that it is that just whatever the output that we get, whatever the output this neuron is giving, over that we are not directly working. It is suppose that giving you output O1. Over that we are not working. We are applying an activation function over O1. And what is this activation function? It is like, say, sigmoid. It may be like ReLU. It may
Relu.
be like tanh. And these are actually non-linear functions. So
Okay,
this
sir.
non-linearity is actually coming because of this. Neuron is actually a linear function, aggregation, simple aggregation, summation AI xi. Is that clear?
Yes, sir. Yes, sir. Understood.
Yes. So that is the reason because of which we are able to learn this non-linear boundaries. If you instead of sigmoid or ReLU or tanh, if you use linear activation function, which is nothing but you just whatever the output that you are getting, you directly pass it on. Then here you will not be able to learn non-linear functions like this. Then you need to learn functions which are piecewise linear like this.
Okay, sir. So activation function causes non-linearity. Okay, sir.
Non-linearity, yes, that
Oh,
is the only part
thank
which is non-linear in this neural networks till now, right? Okay, anyone else who want to ask any question? Activation functions, yes. You wanted to know how can you explain this to class 9 in layman language? Okay, I can tell you that how you can explain this to the class 9. Okay, first thing is that you need to and suppose that you wanted to say this stuff that I am having a neuron like this. So when I say this is a neuron, it is just like me as a teacher. I am a teacher. I am giving you that how you can explain this concept. So please be with me. I am explaining this thing to class 9 or even class 5 or even class 4. Or you can explain it to any XYZ. Now, being a teacher, I am a teacher like a neuron, and I am having my all of my students who are standing like this in front of me. So I am connected to all of you. And why I'm connected to all of you? Because I wanted to tell that whether this class is good or bad. Whether this class is good or bad. So when I say that whether this class is good or bad, I need to come up with different ways by which I can somehow do some sort of formulation of my classification problem, because this is a binary classification problem. Why it is a binary, sorry, why this is a binary classification problem? Because we are only having 1 or 0. Okay, now the point is that being a teacher, while I am teaching, I am learning certain weights. You even as a student or the persons who are attending the class may not be even aware, but I have got certain weights for, say, those who have asking questions. I started to get more weight for them because I understand their name. I got to know that they are asking certain questions, and with respect to those questions, I started to give them certain weights. If you have asked a good question, probably your weight becomes slightly more higher. I wanted to learn W1, W2, W3, and WK. So I am having K students. Over these K students, I am asking, so students, I am learning a weight vector. Weight vector is going to tell you that how much amount of interest I am having, whether I am able to, I am going to use this feature, use this student, or how important this student is for me. And this Wi is actually being multiplied by this xi. And then what you are saying that whether it is more than a threshold, less than a threshold, it is actually going to tell. And what I am doing, I am adding all of this because I wanted to know something about the whole class. I wanted to know something about this whole class. So if you wanted to know something about this whole class, then all the data need to be somehow taken, and then you need to multiply it with all the weights that we have learned, and you will get how many. So for this student, I am giving this weight, so I multiply with that, I take this and multiply with that, I take this and multiply with that, and then add all of this stuff. This is one value that I have got. Whether I'm going to say that whether this class is going to be passed or fail or good or bad, there has to be it has to be more than 25, 30 or 50 or 80. It depends upon if it's a, yeah, if I'm teaching as a teacher, I am teaching history, then this threshold is different. If I'm teaching computer science, the threshold is different. If I'm teaching mathematics, then this threshold is different. So this is the point when you want to say that everything is linear and neuron is going to decide some problem, or some binary classification problem for you. But the point is that sometimes it may happen that whatever I got, that is summation wixi, whatever I got over that, I don't directly work on, I apply some function over that. Now what is that function? Sometimes this function, most of the time it is not linear, because mathematics things are completely different, physics things are different, for chemistry the thresholds are different. So depending upon the subject, I keep on applying function is different. For chemistry the thresholds are different. So depending upon the subject, I keep on applying some function which is converting this whole thing into some fixed value, and over that I apply this thresholding, whether it is more than this threshold. So that can also be seen as different types of scaling that is being done. Because for history, sometimes it's the case that for history, if you have got 70% marks, they may be considered as good, but for mathematics 70% marks may not be very good for you. So probably this is the way in which you can somehow adapt to some 8th, 9th or 10th class students. But I can tell you one thing, that yes, depending upon the students, you need to several times come up with different types of examples and different types of explanations that you can give. Let us see if you want to ask any other thing. Sir, very well explained for the students. Thank you. But it was very randomly created example from my side. But I am sure that you all are teachers and you can generate things better than me. But it was just in the spur of the moment. There are few other things that you can easily add, and I understand, because right from few days I'm continuously giving these lectures. But this is the first time I'm giving for the teachers who are going to teach it for 9th and 10th. Every time they used to ask complex questions, but maybe for the engineering students. So just I've given, but you can add more things, and I'm sure that you can come up with examples which are far better than far better than me. But I understand, and I will try to give with that aspect, that how you can explain this thing to 9, 10th or whatever. But so let me give you one perspective of this deep learning, that why this deep learning is actually different than the traditional machine learning. But we need to understand this traditional and machine learning, because I understand that what I need to cover now, I was in actually a different mood to cover different so many other things. So I need to give you something which is much more basic. So suppose that this is my data. Let us draw it properly. Suppose that this is my data for you, and given this data, right, I need to come up with an algorithm which will convert this data into feature. Now what's the difference between data and a feature? I can tell you that what's the difference between data and a feature. So being a data, suppose that one student is my data. My student is my data. Suppose that let us see. Now I will teach in a very different way. Let us see that who all are there, and I'm not able to see my chats. Some Priyanka was there. Now assume that Priyanka is my student right now, and Priyanka being a student, I wanted to convert Priyanka into a feature vector. Right now Priyanka is converted into a feature vector which is having only one dimension, that is it's her name, Priyanka. Now Priyanka as a student have infinite amount of information. Information. What are they? Her name, maybe age, demography. She must be, got some percentage in 10th, 12th, and so many other things. She must be having her father's name, mother's name. She must be having height, gender, female, and so many. In fact, there are infinite amount of things that I can ask. So how can I convert my data into a feature? I can convert it by asking multiple questions to this data. I ask, what is your name? That is one feature vector for me, feature one. So I ask your name. This is my question number one, and I have got a feature. Then I ask another question, what is your age? That's my question number two, and I have got an answer x2. And in this way, this whole data of Priyanka as a student got actually converted into a feature vector. What is the dimension of such a feature vector? It depends on how many questions that I have asked. Suppose that if I ask only 4 questions, if I ask only 4 questions, then whole Priyanka, which is having infinite amount of information, got converted into x1, x2, x3, and x4. Now somebody will say that what type of questions we need to ask? What type of questions we needed to ask? And that is completely going to be dependent upon what I am intended to do using these outputs. I am getting outputs. What is my intention to do using these outputs? Now suppose that my intention or the or the or the problem that I wanted to solve is that given a data, I will ask questions. Given the answers to those questions, I am going to tell that whether I am going to select Priyanka as my PhD student or not. Whether I am going to select Priyanka as a PhD student or not a PhD student. Then if I ask the name or age or male or female or some father's name or other questions, they are irrelevant. I need to ask, what's your 10th percent? Maybe, do you know Python? Maybe, how good you are in linear algebra? Maybe I wanted to know that what was, whether you, what type of degree you have. Are you a BE, BTech, whatever? These questions are much more relevant if you are interested in the task or the jobs like PhD student selection, yes or no. But suppose that I change my task. This is my task or the work that I wanted to do. Instead of this, I wanted to do my second task, the other task that I wanted to do. This is task number one. When I'm interested to select as a PhD student, I ask different questions. Now I wanted to select Priyanka in my women's cricket team. I wanted to come up with a cricket team, women's cricket team. I should not be asking these questions, Python, linear algebra, 10th class score. I will ask, are you a player? Then are you a batsman or a bowler? I may ask that whether you have played some local cricket, Ranji cricket or whatever. I may ask what is your height. Depending upon that, I can somehow figure out that whether you can be utilized as a batsman or a bowler. Now these features or the questions that we are interested in, these questions, they are going to derive or convert your data into some feature, and this feature is going to be used for some sort of classification, yes or no, whether you are going to be selected or not going to be selected. So depending upon your task or the classification that you wanted to come up with, or the classification that you wanted to do, we need to figure out that what type of questions that we need to ask. And that is why I was saying that initially we were having data, then we have questions, then we have, using these questions, we have got features. Given these features, we learn the hyperplanes, and basically these hyperplanes are classifications for us. Now this itself is actually one area. This is another area. This is pattern recognition or machine learning. This is computer vision, image processing, or other ways by which you can extract different types of interesting or important features that are going to be useful for your type of classification. Classical machine learning like this was actually doing only this stuff. They are not bothered that how your data is being converted into features. They will say that you give me features. I am going to tell you that what is my performance. Basically, I am going to give you a hyperplane or non-linear boundaries like this between these features of the data that you have given. Features are saying that we need to understand that what is your classification problem, and depending upon your classification problem, I'll give you some information that what type of questions needed to be asked, and they will be drafted. And based on the problem, I'm going to tell you what is the problem, and based on the features, I will give you the question. Traditional machine learning, these modern algorithms, modern machines, they were being working in a sync. Now you can say that I am not considering these things as sync things. I am saying what is more significant to one block. That I am inside the
Sir, Aditya sir.
yes.
So voice is breaking, sir. Can you check the net connection?
Voice is breaking. Wait.
Ah.
Okay. Still the voice is breaking. You can write in the chat box. Are
Now
you
it's
able
fine.
to listen? It's fine. Yes. Now it's
Now
okay.
it
It's
is fine.
fine.
So can you
Okay.
repeat from the last step? From
Yes.
there
Yes.
to
Yes.
there. Yeah.
Yes. Okay. I'm going to talk about it again.
Okay.
That machine learning algorithm says that they are looking this as one block, this is another block, and ML and all these pattern recognition books, they start from here. They will say that I am having x1, x2, x3, some features, and over that we are trying to do some sort of classification. They never talk about that how we have got these features. And computer vision and image processing, these algorithms used to say that give me data, I am going to give you how I can convert this data into x1, x2, x3, x4, the feature representation. And this was a traditional machine learning approach in which features are coming from somewhere and classification is being done separately, and both of these things are not communicating to each other. In the case of deep learning, it will say that I am a single algorithm, one single person who is going to manage features as well as classification. So what type of questions need to be asked is completely driven from the classification. So if it is a cat and a dog classification problem, I am going to say it and ask different questions. If it is male versus female problem, given an image, if I say that whether it's a male image or a female image, my questions are going to be completely different. So what is going to happen in the case of deep learning is that everything is combined into one single block, and one such a single block is going to tell you both of these things are working in a sync, and questions need to be designed in such a way so that they can actually be given to the classifier so as to solve the final classification problem. So no, now feature and classification, they are not two distinct entities in the case of deep learning, but in the case of traditional machine learning, some guy was doing this, some other guy was doing this, and they were not communicating. So if your classification is not performing, every time classifier guy can say that the features are not good. And if features are not performing well, they will say that my features are good, probably your classifier is not now working. When both of these things are combined, they cannot say that this is good or this is bad. Both of them has to be good, as well as cooperating. Features need to cooperate with the classifier, and classifier need to manage itself in such a way so as to cope well with this, whatever the features that we are getting. Is this okay and clear to everyone? You can write yes sir, no sir. Yes, Tushar Upadhyay, good. Yes, 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 understood. Yes, fine. Now let us go and talk about few. So I have actually got up to here. Now I wanted to first of all give you the basic magic. What is the magic? Because sometimes what happen that you need to uh, give students that what these algorithms are able to do in plain and simple words. So you can show them that this is now possible, which is actually like magic. What it is? that these are few images, and now you can see that actually I am having image like this. So can I take this image and can I match this image with this image? Then you will say that, see, here I am able to see full image. Okay, here I am able to see only half. Can you generate from this the other half? And now if you wanted to have image number 1 and image number 2, can you match? From image 1 and 2 you cannot match, but from 2, let me write, from 1 and 2 we cannot match, but if I convert 2 into 3 I can match. So how can I match now is that I will now be matching 1 and 3 because they becomes much more similar. So what we have done in between, we have generated the other half, because only this half is being shown, maybe only this half is being shown to you. How can you generate this part? So these deep learning algorithms are actually able to generate things like this. From this, the part which is not even available, can you generate that? This is one problem. Now you see, object detection and recognition. Any computer vision task, if you wanted to do, artificially networks are learning and trying to do things for you. First thing is that, can you detect a thing automatically and recognize it well? Detection as well as recognition, both of these things, is it possible? Which means that given any image like this, I need to come up with, okay, this is some domestic cat, this is the TV monitor, this is something, this is something. Or if you give me an image like this, I can even tell you that where is the banana, where is the orange, where are different oranges, and then I can say that even you can you count that there are 4 oranges and 2 banana. So object detection is something which is essentially required, and then object recognition. You detect and say that there is something, that is detection, and there is banana, this is recognition. So object detection and object recognition automatically given any images, there are now deep learning algorithms which are very easily doing this stuff for you. Now see that automatic colorization means that I'm having images like this, black and white images. Given images like this, I can convert them into images like this, which are colored images. So given any input like this, I can convert into the colored part of the images, and then you can see that this was the actual colorization. Or I have actually a image like this, I converted into a grayscale, and from this grayscale, if I convert it using some automatic algorithm to this, now you see that how well I can generate colorized image out of this, and how you can say that close they are in the colorization. There is another set of problem that we wanted to see, is that if I give you images like this, you can see that images like this. So these are noisy images, huge amount of noise is there, and using algorithms that we have just deep learning algorithms, it can convert this into this. That is actually what? This is denoising. This is denoising. What is super resolution problem? Super resolution means that if I give you an image like this, now you see that it's such a very small, this image itself is having certain things. If I choose a very small part over here, probably you can see this part. Some is, some square is there. If I take that small square and make it in such a way like this, that is super resolution. Now you see that why we want to do super resolution. Suppose that if you have microscopic images and you wanted to see what is the macroscopic structures which are available in that microscopic images, several times we need to do super resolution. So from small images, how can I convert them into big and big resolution images? Image imprinting, this is the problem in which I am having image like this, in which certain part is hidden, and I can regenerate that part for you. This part is hidden, how can I generate that part for you? That is imprinting. Then there is artistic style transfer, in which I am having image like this, Okay, I'm having another image like this. Now you can see that both of these images are completely different type of images. But is it possible to have content of A and style of B? Can you see content of A, which is actually a pen pencil sort of image, and this is actually a photograph. So content of this and the image or the style of this, you can have something like this, or content of B or style of A. That is style transfer, and it's actually being done using deep learning algorithms. Similarly, there is possible that now you just generate this, or you generate doodle something like this. Doodle is like that you take pen pencil and do some random stuff. It's very rough sort of image that you are giving, and from this I can generate original actual images for you. So this is also possible, that is semantic style transfer. I'm just giving you the name. Maybe names may be slightly complex for you, but I'm also trying to explain in very simple language that you just give, some doodling or some rough sketch of an image. And you see that here you have said that there need to be some water, there need to be some sky, and every time whatever you are drawing, it already understood the thing, and because it knows how can I make sky, how can I make water. So it will do things for you automatically. Now you see that style transfer, if you give me input like this, bag out, just the outline of a bag, whole bag image will actually be generated for you. If you give me a day image, how can I convert it into a night image? Now it comes that if you give me a horse image, how can I convert it into a zebra image? That is actually unsupervised image to image. So now you are giving me images, and I'm converting this image to another image and related image. So from horse I cannot convert it into a human image, but horse I can convert it into zebra in a best way. So what it is actually done, that it understands that where is a horse and how I add strips over this horse to convert it into zebra. Other things remains to be the same. So it's a very intelligent system which is actually able to understand that there is some horse, and I need to first of all figure out that where is the horse and how can I convert this horse into a zebra. Now it comes much more complex thing, that right now it was that image. I am at least giving you an image and you are converting it into an image. Now instead of that, if I give you only the text to image, you need not to even give me an image. You need to write there is a bird, has a yellow belly, taurus, gray black wings, throat nape, something something something, blah blah blah. And it's now, this is actually this, no such bird exists in this universe. This is just being created by neural networks from this text itself. This text converted into an image, this text converted into an image. There is no such flower which is available. This is the input and this is the output of the neural algorithm, which is trying to do things for you. The name is stack GAN. And there is another better version of the previous algorithm which will started to understand and started to give you even better results than the previous. Now you see, this is the sentence from which I need to convert it into a image. This is actually text to image. This is the text for you. Out of this text, it understands there are certain parts which are important. All the things are not important. I need to figure out that there need to be a bird. So first of all, I need to know that I need to draw a bird. It has to have some sort of yellow thing. So that's why yellow color is being implanted. Some black or eye rings. So eye, and there has to be some eye. It has to be black and it has to be round. So you see that it has started to give attention to different parts of the sentences, and because of that it started to perform better than its previous version. So essentially this attention GAN or stack GAN, they are actually the networks. They are converting text to images which are photorealistic images for you. So this performs really very well in such a scenario. Let us have few questions. Yes, raise some hand. Okay. How can I see? My own. How can I see that who has raised? Oh, why it has happened? Wait, where I have gone? Hello, can you listen?
Yes, sir. Sir, if click on FTP, then it will come online. FTP on AI and top green bar.
Yes, something actually I have done and I am not sure. There is a call which is on. Oh, I'm here. Right. I'm sorry. So now you can ask any questions related to whatever I just have covered, and then I can talk about these image convergence, where it is used in which industry. Wow, that's great question. Okay, so first of all, you must have seen that there are so many apps which are coming that will take one image and convert it into an aged image. You can see image in which you just send your image and it started to show how how will you look like when your age is 30, 40, 50, 60, 70. So face apps, yes, face apps it's applying. uh, there are so many algorithms which are doing face touch up, like you wanted to do beautify algorithm is actually essentially doing the very similar thing. Criminal investigations, it can be used, yes, that is anyways my area of research in which we used to work on different face recognition algorithms and all. Yes, beautify is actually a tool that you can very easily relate. Yes, yes, yogini. Oppo cameras, yes, if you see any Oppo camera or any algorithms in which image to image, you are seeing one image and your image is converted into some other image. Maybe they are creating a better or a beautified image. Sometimes they may create a poor quality image. Sometimes they wanted to make okay, is the computer vision application required for conversion of this? Yes, yes. So for all these things, computer vision algorithms are actually required. How can I see these chats in a much more systematic way? In call messages from here, I guess. Okay. Ani, is the computer vision API required? Yes. Yes, APIs are required and they are publicly as well as available, as well as their online versions are available. Whatever thing that you are able to see in which you give one image and got converted into some other good or bad or some other quality of image, other type of image, essentially they are using the type of application that I just have shown it to you. Exactly same. So all the vision companies, they are trying to do this stuff. And there is actually like image to image, this video colorization is also one point. You can see. So deep learning is yes, deep learning is used not only extensively, but each and everything that you see. Suppose that Google is doing something, language to language translation. You write it in Hindi, it will convert it into English, French, Japanese, whatever. Deep learning is there. um, if you see any face recognition, deep learning is there. Face detection in your camera, speech recognition, deep learning. Everything deep learning. Whatever you see, Apple, Facebook, Google, everything is deep learning right now. Without deep learning, no artificial intelligence. Right now it is the state of the art. Every state of the art algorithm is actually deep learning based algorithm. Either it is in computer, yeah, it may cut off the noise and convert into text. Yeah, it will convert the noise and cut off and converts into text. It can, yes, it can do that thing as well. On it's actually online. You can do, you speak in Hindi and it will online convert it into Japanese speech itself. What is the need of? Yes, that is the thing that we talk about. Just see, Jasila Sayed. Yes, we will talk about that. Yes. But first, I need to motivate all of you that yes, it's happening. To guess something substantial from something ordinary. Yes. So, substantial, it's actually learning. And not only from ordinary, Rini has written exactly that noise. Ordinary is even, something which is okay and fine. even if you give me noise, I can remove that noise, I can convert that noise into something better. Yes, Mithilesh, every phone and all these phones are actually having very similar algorithms the way I just have shown it to you. Several times given in your iPhone and other phones, if you see, it will take these images and classify them as indoor, outdoor, food images, transport images, sceneries, selfie, background. They converted it in that way. And if some of you may be having iPhones, so iPhones are already doing huge amount of processing in the backend over their iCloud, and they started to give you that you just tag one name of one person in your photo, and it will tell you the in whole of your if I say dictionary of images, it will tell that where this person exists, who is he. You just have to show it that okay, this is Aditya Nigam, then it will go into your database, see each and every image and tell you that what are the images which are belonging to this ID. Yes, good advertising. Right now deep learning do not require any advertising. Advertising is only being done for those which do not have the potential.
Sir, this algorithm of searching
Yes.
images is also there in Google
Yes.
Photos. If Google Photos अगर हमारे पास है, तो we can search by showing one image. Just Google Lens से we can scan one image that we want to see this, or we can select the picture and it will show all the pictures available. It is
Perfect.
newly added features in Google Photos.
Yes, this is perfectly correct. And what I was trying to say is that ये सारी algorithms deep learning की हैं. सारी की सारी algorithms ही deep learning की हैं. और
Yes, sir. Yes, sir.
और जसीला मैडम ने जो क्वेश्चन पूछा हुआ है उसका वो बात है कि ये सारी चीजें जो मैंने आपको दिखाई, इनको करने के लिए हमें कॉन्वोल्यूशन लेयर्स का इस्तेमाल करना. वी नीड टू यूज कॉन्वोल्यूशन लेयर्स एंड डेंस लेयर्स एंड हाउ दे आर डिफरेंट. This is the thing that we need to understand, and we need to do this thing to somehow come up with these algorithms. ये सारी algorithms convolution layers का इस्तेमाल करती हैं और dense layer का इस्तेमाल करती हैं. Yes. If you have any other question, please ask, or you can write there in that ये इसको क्या कहते हैं, messages. If this is okay, then we need to understand that dense or fully connected. So just okay, yeah. So dense and fully connected, they are same. If I say that why it is dense, because everything is connected to everything. Yes. What is this? Yes. So let us go and yes. So when I say that this is my input and this is my one layer of neurons, okay, everything is connected to everything mean that all of them are connected. Then they are also connected. Then this is also connected. Right. So how many weights are there that we need to learn? We need to learn 5, 3, and how many weights are here? 5 into 3, 15. If I have N1 here and N2 here, then how many weights? N1 into N2. Because everything is connected to everything. Now suppose that if I have an image like this, and image is having a typical resolution, which is something like this, a typical resolution, and suppose that this is 100 and this is also 100. Now you just think about 100 by 100 is a very small image, very small image. 100 by 100. I take this 100 by 100 and say that this is pixel number 1, pixel number 2, 3, and so on. This is 100. This is 101, 102. Keep on doing 200, This is 201, 202, and keep on doing 300 and so on and so on. And this is 10 power 4. Fine. Now I unwrap this image. This is called flattening. Image flattening. Now this becomes pixel number 1, pixel number 2, so on, then pixel number 100, which is up to this. And then I take this pixel and place it over here. This will become 101, 102, 103, and so on. And then you will become 200 and then so on, keep on doing, and then you become 10 power 4. Now you see that how many, what is the input dimension? Input dimension is 10 to the power of 4. So what is your n1 over here? My n1 become 10 to the power 4. Okay. My first layer of neuron is going to have, suppose that weights like this. How many? Suppose that it becomes 1000. Okay. Then your n2 is actually equal to 10 to the power 3. How many neurons or how many weights we are going to have? n1 into n2. How many? 10 power 4 into 10 power 3 equal to 10 to the power 7. Is this computation clear to everyone? Computation clear to everyone. Let us see. Yes, sir. Yes, very easy and simple, straightforward representation. Good, you all understood. Yes, so what I wanted to show is that if you take an image and how much was this image? It's very small. 100 by 100 image is a very small image, maybe something like this. Usually we have 1024 by 1024 full HD or something. But if such a small image, and how many parameters or how many things that you need to learn? How many things you need to learn is this, which is actually a very big number. 10 power 7 things that you need to learn. This means that yes, although not Jasila's question, we are going to somehow manage that. Yes, if you wanted to have a fully connected or the dense network, if your image is even such a small 100 by 100 image, first layer itself is going to have 10 to the power 7 learnable parameter, which is actually a very big number to be learned. You need to learn 10 to the power 7 floating point values. Decimal number honge ye sare, and you need to learn that. It is going to take huge amount of data to learn such a thing, and huge amount of time as well to learn such a thing. So is this okay? We all understand? Jasila, you also understand?
Yes, sir. So first we are flattening the image. The 100 by 100 we are flattening and making as an input level layer. Is it?
Yes, that is correct. That is correct.
Okay.
So
Okay,
once you
sir.
flatten this 100 by 100 becomes 10 to the power 4. And suppose that you have got 1000 by 1000 image, then it becomes 10 to the power 6.
Yes,
So
yes,
huge number
yes,
of
yes.
things. Yes. So that is the problem with the dense layer networks, that we cannot apply it directly over the images. You will not be able to apply because this becomes very big. Okay. Now, instead of that, what we used to do, what we started to do is that we started to take this image and started to apply another type of filtering, and this filter becomes, say, 3 by 3 filter, and it started to work well. And what so this is actually, first of all, convolution, and that we will talk about in our next lecture. But before going to talk about that, some small intuition, that since you cannot flatten your image and big images and apply dense layer over that mean, this is one problem, that we are going to have huge number of parameters. But that is not the only problem, that only huge number of parameters. The other problem is that
why this image is an image? Let us see. Why these pixels are not random pixels. These pixels are actually a image pixels. Suppose that I'm just writing something. Okay, I am writing 7. Why this 7 is there? Why this 7 is there? First of all, we need to understand how this 7 is actually must be written. This part is blue, this part is blue, this part is blue, these pixels are blue.
The number of pixels which are lighted up there.
Yes.
White.
Yes, right. So they are actually blue. Now there is actually a spatial relationship. What is that? Why this pixel is blue? Because this is actually the part of my 7. Why this pixel is blue? Because this is adjacent to it. Why this pixel is blue? Because this is, some part of my 7, and because of these pixels and their combination, this is actually becoming 7. So there is some spatial relationship. What is this spatial relationship? Now, in an image, suppose that I'm talking about a pixel. I'm talking about this pixel, and this pixel is say white. Why? Because that's a pixel of my background. Okay. Suppose that in an image, I'm talking about some image of a face. This is the face image, and these are eyes, and this is my hair. And why this pixel is black? Because this is the part of the hair. Why this pixel is black? Because this is also the part of the hair. Why this pixel is having a brownish color? Because that's a part of my forehead. Why this pixel is actually having some black part? Because they may be mustaches. And suppose that I am working on face images and I wanted to figure out whether this guy is male or female. This face is of male and female. Maybe that this part is going to give huge amount of information. Why? Because suppose that I am having mustaches, very easily you can say that this is male, and male probability is very high. And suppose that at this place, if I got a some very some bindi or some sort of ornaments which are being wearing this guy, or some makeup is being actually seen, hard makeup, then probably you may say that okay, that's more probable to be a woman. If I show you the eyes and why these eyes are actually in a particular way, that is the spatial relationship is actually being there. First of all, we need to understand a image is a image, and pixels are having a very specific values. These pixels are having very specific values because they are having a deep relationship between them. This is a hair pixel and this is also a hair pixel, and they are nearly very near to each other. That is why they are holding a very special type of spatial relationship. First thing, when I flatten a image, flattening a image is actually saying how it is being flattened. Suppose that this is row number 1, row number 2, row number 3. This is row number 1. All these pixels are row number 1. All these pixels are row number 2. All these pixels are row number 3. All these pixels are row number 4. How I am flattening? This is row number 1. This is row number 2. This is row number 3. And this is row number 4. So that is actually flattening. This flattening is actually disturbing, basically losing the spatial relationship. Do you see all that stuff? Because then what will happen, that these guys will be, suppose that are here, and these guys will actually be here, and then you will see that there was a relationship that they are close, but they are also close, and they are also close. So this 3x3 neighborhood, or a patch label neighborhood, or this sort of relationship that this is having, that a pixel which is here, it's having a relationship with its 3x3 neighborhood. This spatial relationship is actually disturbed. completely disturbed, and because of that we will not be able to see image in a totality. So one reason is that you are having too many number of pixels. Second is that a spatial relationship is actually disturbed, and because of this we do not take image and directly flatten. We take an image and apply convolution filters over that and keep on reducing the size and keep on getting the better and aggregated features, and the features which are, keep on accumulated and aggregated over a period of time, that we will see layer by layer. And once you have got a small feature vector, only then you can open it. Before that you cannot open. Yes, so this is the layout that I wanted to first make before going to talk about CNNs, and then later we will talk about convolutional neural networks. Let us see arranging serially. Yes, that's being arranged serially. Yes, row wise, one by one. Coordinates of every piece will be fixed. Yes, in an image, when you have, you know acquired an image, x y in that two-dimensional space, all these points are actually fixed. So yes, images are having, suppose that it's 100 by 100, then you are having 100 rows and 100 columns. Let us see any other question.
Aditya sir,
Yes.
actually, since participants are school teachers, they may not have some basics of image processing.
Okay.
You have given enough idea about the images. Maybe in the next session you could talk about some 2-3 minutes about the images, then we can go for convolution. Is that fine?
Yes. So in the next lecture, I will first talk about the basics of
Basics of
images.
image processing, and then we can go for convolution, then CNN.
Yes.
So let us take the break 11:30, and we can assemble at 11:45. Is that
Okay.
fine? Yeah.
Fine.
Okay. Some 5-10 minutes introduction about images will do.
Yes. Yes.
Yes.
Yes.
Thank you, sir.
Okay. Fine. Thank you.
Okay.
Excuse me, Umarani ma'am.
Yes, sir. Yes, ma'am.
Ma'am, can you give us 1 hour time to write the exam, ma'am?
Okay, ma'am. We will do. No issues.
Because it's very short time. I felt that we can't do it.
Okay, ma'am. Okay. We will
Please
do.
extend the time, ma'am.
Okay, okay, ma'am. It's all on your convenient only, so we will do.
Thank
Whatever.
you so much, ma'am. Thank you
Okay.
so much.
Okay.